Hello everyone, thank you for providing me with the opportunity to present this work. My name is Ricardo Correia and I'm a software developer at Flutter Entertainment. I also am a student at Polytechnic of Porto, finishing my master's degree in computer science. Today I'll present you with the methodology developed by me, Cristóvão Sousa and David Carneiro, to tackle the different data quality issues found in the IoT environments today. Let's first dive into the data management iterations that we took. So the first was the implementation of a data lake, then we moved on to a data fabric-centric application, and then we incorporated some principles of the data mesh architecture. The first iteration was to implement a centralized repository that consumes the whole data from one IoT environment. This, in theory, could increase the data visibility and discoverability of the whole system. In practice, this did not turn out as so, since the more complex our data got, the more complex it turned out to be to reach the data. This led us to the implementation of a virtualization layer as a data fabric principle. So this virtualization layer would hold our whole metadata around the data that we have in our repository, allowing to create context values around that, increasing data quality and the overall discoverability. Then we incorporated the data divisions as a data mesh principle. This allowed us to create data ownership and thus creating better data quality guidelines. Let's now talk about data observability challenges. Data observability is one principle that should be taken in consideration when designing a data management tool. This allows us to understand the health of our data and if it's impacting any other end services. Data observability is centered in 5 pillars. The first one is freshness. So this allows us to understand how recent is our data, especially in the IoT environment. This is important because in the IoT we either are fast or irrelevant. The second one is distribution. This allows us to understand the values that our data can have. So if we have values that are constantly out of these bounds, we know that data is not healthy and it might be impacting the different end services. The third one is volume. This allows us to understand peak consumptions of data or even downtimes. The schema is what allows us to understand the schema evolution over time. And the last one is data lineage. This is a particularly important one since it allows us to understand what kind of data processing have our data gone through till it reached the endpoint. So if we have faulty data, at some point we can go back and understand what caused that data to be faulty. Another point that we focus in our development were the FAIR data principles that focus on data quality in the different vision. So the FAIR data principles focus on the discoverability of data and is centered around 4 key principles. The first one is findability, defining how data can be found. The second is accessibility. After we find that data, how can we access it? Interoperability defines how can we integrate 2 different data sets, and reusability is said to be the ultimate goal of FAIR data principles, is reuse data that otherwise would go to waste. Now, before reaching our solution, we need to define data inside the IoT. So we divided this definition into separate categories. The first one is the actual data read by the sensors. So this data is known to be faulty and error prone, and we need to create data quality centric approaches to improve our resilience as an application. This resilience can be achieved by the context metadata, which contains the context of the data that we consume. This has all kinds of values to allow us to understand how data is being consumed, what data actually is, and how it can be used to further extract information. The context metadata can also be divided. The first one is the computed metadata. This is a metadata that can be continuously calculated throughout the data life cycle. So as we consume more data, we can get a better overview of these metrics. So some examples include statistics, lineage, distributions, and freshness. The other section is semantic metadata. This allows us to understand how data is correlated with the whole system, creating and understanding how can it be further utilized to create better information and knowledge about the physical environment. Now we'll talk a bit about our solution. Our solution is composed by three centric components. The first one is context broker. Then we'll move on to the data gateway, and underneath the data gateway are the processing pipelines. So the context broker is responsible to consume the whole data from the IoT environment and keeping a record of the metadata that is surrounding it. So in this component we have a full overview of the context metadata that we have, including the semantic net, the entity properties, the whole different entities throughout the IoT physical environment. These can be sensors, rooms, vehicles, anything that can produce data and can be correlated to other data. So after we consume the data in our context broker, we'll move on to our data gateway. This is what contains our whole data throughout the different life cycle. So our data gateway contains different data stages. These data stages corresponds to different data maturities and data ownership. So we have a data stage per maturity and per business ownership. So after the data is consumed by the context broker, data is then passed on to the first data stage, which will contain raw data that can be consumed by underlying pipelines to produce better understanding of that data. So by designing our data gateway as a centric access to data, we can have different processes that can be plugged into it. So that's how our pipelines are designed. These pipelines are plugged into our data gateway. They do some kind of data transformation, creating a data pack, which is a iteration over our data, creating either a decoration or data quality metrics or anything that can be used to understand data better. And this allows us to move one data from one data stage to another data stage. And by doing this, we can continuously iterate over data. The processing pipelines move data across data stages, but also feedback data quality metrics to the context broker. By designing data gateway in this form, we can plug in other processes, as we see above the data gateway. So we have some examples such as alerting, database for archival processes. We also have machine learning processes that can be taken in consideration, and we also have data visualization tools that can be plugged into the data stage directly, so users can understand the data that is gathered around our system. This was what I had for you today. Thank you for letting me present this. I hope you're finding it interesting. I can be reached via email for further questions. Thank you.